In this lecture, we want to have the ability to add items to our collection, which is box container that we just built in the last lecture. What we are going to do is go from a setup like we have here. If you go in here and count the elements, you're going to see that we have 1, 2, 3, 4, 5, 6, 7 elements. So our size is 7 and our capacity is 10. We want the ability to add new elements. For example, we can add a 5 here and a 6 and a 7. We want these kinds of things in our collection here. And we are going to go through a bunch of methods that we set up. So to add an element, for example, we can add a 9 and the size is going to go up. We can add a 15 and the size is going to go up, and we can add this 17 and the size is going to go up. If we hit maximum capacity like we have here and we want to still add another element, we want the ability for the current collection to grow its size or its capacity to account for new elements that we would want to add. So for example, we could extend our capacity and add 3 more slots that we could use to store elements. And one of those slots is going to be used to store our new element, which is 18 here. And our size is going to increase and the capacity is going to increase to 13 at this moment. I think if you count, you're going to have 13 slots here. This is what we want to do. And we're going to see a bunch of methods we can set up to do that. The first thing we want to do is the ability to expand our collection. So we will set up an expand method. This is going to be a member function of box container as you see here. The first thing we're going to do is set up a pointer which is going to be storing the new array if we want to create a larger array which is going to have more capacity in. Because remember, an array is a fixed size container, so the size doesn't really change. If we want to store more elements in our collection, the only choice we have is to use a new larger array and storing copies of the current element, and we are going to destroy the current array. This is what we are going to do here. That's why we set up a pointer to a new items container here. Now we have to check and see if the new capacity is greater than the current capacity. If it is not greater, we don't really need to set up a new array, because setting up a new array is a lot of work, so we need to do this kind of check here. Once we know that the new capacity is larger than what we already have, we are going to allocate a new dynamic array which is going to be larger. It is going to be using the new capacity, and we are going to copy elements over from the old array. So we are going to be looping this number of times, and we are going to be copying elements from the old array into the new array. This is the syntax we use here to do that. And after we have the elements copied, we are going to destroy the old array, and that's how we do this here. After we destroy the old array, we are going to be reusing its pointer to point to the new array, and this is how we achieve this. We take the pointer to the new array and assign that to the old array. This is going to make our mItems pointer still work. After we do this, we're going to set up the capacity to be the new capacity. And we are going to do that down here. And I know some of you must be asking, don't we need to change the size? But the size doesn't need to change, because what we are just upgrading is the capacity of this container here. And we are going to be using this method to expand anytime we need more capacity in our array. Take some moment to let this sink in your brain, because it can really be confusing, especially for beginners. And let's move on and see how we can add elements. So we will set up a new method to add elements to our collection. It is going to return nothing, and it is going to take the element that we want to add. Notice that we are passing in our type alias, and this is going to automatically pick up the type that we set up for this type alias in our header file, and it is going to work really well. We will have the flexibility to change the type we store in our container on the fly, and that's going to be really cool. Before we add a new element, we are going to check and see if the container is not to maximum capacity, and we do that by checking it to see if the size is not equal to the capacity. If that's the case, we are going to expand our collection by 5 elements. We can do something like this. If you want, you can change this number to 10, 20, or whatever. This is going to be the number of slots you add if you need to expand the capacity. After we do that, we are going to add our new element, and the slot we add that is going to be the index of the size of the element. And this is going to be our new element. And after that, we are going to increment our mSize member variable. This is going to add our new element, and it is going to be updating the mSize member variable to take into account the new element that we just added to our collection. Okay, this is what we are up against in this lecture. So let's head over to Visual Studio Code and actually do this. Here we are in our working folder. The current project is adding items. That's what we are going to look at here. And we will be reusing the code from the last lecture. So let's do that and copy everything. And we are going to put these guys in the current object and use this as a starting point. And let's open this up in Visual Studio Code by dragging and dropping here. We have our box container class like we had in the last lecture, and we want the ability to add items. As we have seen in the slides, we are going to have to add two methods. One is going to be the expand method, which is going to expand the capacity if we have run to maximum capacity in our collection and need to store in more elements. And we will also put in an add method, which is going to add an item to the collection and store it in. Because of that, we will no longer need this dummy initialize method because we will have the ability to add items on demand, and this is going to be much more flexible, so we can completely take this method out. The other thing I want to do before I set those things up is to set up another static member variable, which is going to be storing the expand steps, and this is going to be the number of slots we are going to be adding every time we expand the size of our collection. We are going to put in a new private section, which is going to store our expand method. Let's do that. And the reason I make this private is that this is really not meant to be used from the outside. This is meant to be used internally by methods that manipulate our collection to expand the size. So we are going to say void expand, and I think the type is size t, and the name was new capacity. And we also need an add method, which is going to add a new item to the collection. And we can go up and say that, and it is going to be void add, and we are going to say const value type reference, and we can say item here. This is going to do, and once we have these in, we can put implementations for them in our CPP file. Let's go in box container.cpp, and we are going to go all the way to the end. We can put in the implementation for our expand method first, because that's going to be needed by our add method. Let's do that. And we can just copy the signature of the header and put that here and say that this method belongs to box container. And we are going to put in a body. And inside, we are going to do everything we did in the slides. So we are going to set up a pointer, which is going to be pointing to our potential new larger array, which is going to be a dynamic array, dynamically allocated from the heap. We are going to check and see if we actually need new capacity, and if we don't, we are going to get out of this function because setting up a new larger array is really a lot of work, so we don't want to do this unnecessarily. After we know that we need a new larger array, we are going to set that up using our new operator. This is going to dynamically set this up from the heap. Notice that we are using our new capacity, which is larger than what we had before. And after that, we are going to loop and copy elements from the old array and store those elements in our new dynamic array here. After that, we are going to release our old array and make our mItems pointer point to the new array that we just allocated here. And after that, we are going to update our capacity. This is going to make sure we set up our new capacity, and our array or our collection is going to be wrapping a much larger array, which can account for more elements than we could store in our collection previously. This is what we want to achieve here. Once we have this method, we can put in our add method, which is going to be using our expand method. Again, notice that our expand method is private. We don't want this callable from the outside. It is meant to be used internally in our box container class. Let's set up our add method. We're going to put that in here and say that this belongs to box container. And we are going to put in a body. we are going to check and see if the collection is not to full capacity. And if it is to full capacity, we are going to expand it and make it contain more elements. Notice that we are adding expand steps. And if we hover over expand steps, we are going to see that it is a 5. So we are going to be expanding this by more 5 elements to account for the new elements that we are storing in here. After we are sure we have enough capacity, we are going to store the element at the last index we have, and that happens to be M size. So item is going to be stored in the last slot in our collection. And after that, we are going to increase our size to account for the new element that we just added. And this is really all we need to do in this lecture. Now that we have this, we can go to our main CPP file and actually use these things. We don't need dummy initialize anymore. And we can actually take everything out and put in a new piece of code that we can use to make sure this is working as we want. So we are going to set up a box object, and we can add 11, 12, 13 to it and see that the data has actually gone inside. After that, we are going to add a 14 and a 15 and print this out and see this going in. We can add a 16 and we can loop around adding elements and see these things really happening. Let's make sure we see our capacity. The default capacity is going to be, let's see what we have. The default capacity is going to be 30. So we can bring this down to a value that is going to allow us to see things expanding. So let's make sure we have in maybe a capacity of 5, so that if we add a 6th element, we're going to see things expanding. We can go in and change our default capacity to 5, or we can even specify 5 in our constructor here. This is going to make sure we have a capacity of 5, and we can try and run this program and see what we get. Let's pass this through GCC, our favorite compiler. The build is going to be good. We can bring up a PowerShell window to really try this out. If we run Rooster, we are going to see things happening. So by default, we have a capacity of 5. So if we add elements 11, 12, and 13 and print this out, we are going to see 11, 12, and 13 here. If we add 14 and 15, we are going to see that here. But if we add a 16, we are going to be trying to use more than we have in terms of capacity. So we will need to expand our collection to 10. You see, we are expanding to 10 and put in our 16 here. And after that, we are going to loop around and add in elements. We are going to add 4 elements. And at some point, we are going to run out of space. And we are going to expand our thing to 15. And we are going to be storing in all this data here. And this is what we have. Our thing is really working as we expected. We are using our add method, and the add method is internally using our expand method, if necessary, to expand the capacity of our collection here. This is really all we set out to do in this lecture. I hope you found it interesting. We are going to stop here in this one. In the next one, we're going to see how we can actually remove elements from this collection and set up a bunch of methods to help us do that. Go ahead and finish up here and meet me there.